Good morning, everyone. Some time ago, maybe it was quite a while ago, I created a Unity tutorial which showed you how to make a web request using REST and receive some JSON data. It wasn't that good, to be fair, and I had some comments about it, people wishing I'd done more. So I'm going to redo that video now, and we're going to make it a bit more useful. So in this video, we're going to make a weather app. I mean, there's millions of those, but frankly, I think there's a gap missing for one with a terrible UI, and that's what we're going to do. So let's get started. So let's talk about what you're going to need for this tutorial. First, you're going to need Unity, obviously. Just so you know, because versions and you know, if a tutorial gets old, then sometimes it becomes irrelevant. But for this, I'm using around the 2019 version. They're making updates pretty frequently, but you should be okay if you're around that sort of area. The other thing that we're going to need is we're going to need an account with openweathermap.org. It's free, at least it's free for what we're going to be doing. So you just sign up with them, and then we're going to go to the API, and the bit that we're interested in is the current weather data, because that's what we're going to use. And if you scroll through this, you'll see that returns some JSON here. For those of you who don't know, JSON, as in JSON, not my name, it stands for JavaScript object notation, and effectively it's just a JavaScript object. And it's pretty much the de facto way of passing data around with REST APIs. So let me just scroll this up. This isn't working too well. So if we're going to copy that, we'll just copy that because I want to show you the next thing that we're going to need. We're going to need this website here called JSON to C#. Now what this does is it creates JSON to C#. It's all in the name, really. If we just didn't copy it, hang on, damn it. We just copy this and then paste it in here. I'll show you what it does. Don't worry about generate with QuickType. We don't need that. Just click on the generate, and you'll see that it creates C# classes for us, which is really nice. Saves us quite a lot of effort. There is something that you should be aware of, though. It works really, really well, but it can only guess from the data that you provide it. So in some cases, you're going to find that it's picked the wrong type. Now, looking at it, lat and long, that's come out as whole numbers, so it's guessed it to be ints, but I'm reasonably certain that there's going to be quite a few cases where these come with a decimal point, at which point when you're running your code it's going to throw up an error, and we'll probably see that later on. In fact, I have a sneaky suspicion we will. But anyway, we'll show you that. I mean, it's good debugging thing, but it's just something you should be aware of, that we're probably going to need to change these to doubles at some point. But anyway, doesn't matter. The next thing that you're going to need is you're going to need something to test your API, web API calls. And for that, I would recommend using Postman. It's pretty cool. So if you download and install Postman, if you don't want to use Postman, there's some others out there that you can use, Insomnia or Swagger or anything else, but for the purposes of this tutorial we're going to use Postman. Okay, so the next thing we're going to do is test out that our Open Weather Map API key works. Okay, so I'm going to assume that you've created your account and you've gone into the API keys and you have your API key readily available. What we're going to do is we're going to use Postman to test that this all works. The first thing to note is that in all the examples here, they don't this isn't complete. Now there may be in the documentation it does show you how to make that complete, but just to make this really easy, if you cut and paste that, what we're going to do is we add the HTTPS // on the front of it, and then after the Latin long, so Latin long here, you're going to put an @ sign and you're going to put units equals metric, and then you're going to put @ sign and then in capitals app APP ID equals and then your API key. Okay, and that forms the full request then. So if you cut that or copy it, whatever, and then open up Postman, okay, we're going to create a new request. Okay, we'll just paste that in and you'll see that it's put the query parameters here. Everything's all there, nice to the Latin long and metric, etc, etc. If we send that, what you should do is you should get the result, and now we know that it works properly. Now you'll see here that the Latin long has come with a decimal place, which is something that I highlighted earlier, but I'm still gonna show you how that's going to error out anyway. So now that we've tested that works, let's get into Unity. Now we're going to get into the interesting bit, which is dealing with the web request in Unity. But we're going to start by looking at the JSON aspect. Unity has its own classes to deal with JSON, and if you check the Unity docs you'll see what they are. But I've tried them out, and in my view I don't think that they're not quite as useful as something called NewtonSoft JSON.net. Now NewtonSoft JSON.net is pretty much, certainly if you're a C# developer, it's pretty much the standard library that you use to manage JSON. Now I assume, and it is an assumption, that the reason why Unity haven't chosen to use that and create their own is probably because of its overall footprint, and I guess that the Unity version is a lot more lightweight and doesn't have so many functions. But in my view, and certainly with the projects I've done, there's no reason not to use JSON.net. It's just really good. Now, how do we get it into Unity? You can actually import the DLL into your project and use it like that, but I found that it works on the desktop version, but I couldn't get it to work on a mobile device, and I expect that's probably because of versions and whether and so on. But the whole point about being a developer is not reinventing the wheel or reinventing code, because people have already done this stuff 1,000 times before, and really what you want to do is you want to be making games, you don't want to be creating libraries. So the first step is always to go to the asset store and see if someone's already done this. Now, obviously, this is contrived because I certainly know that someone already has, and as you can see, there's lots of them here. But I'm going to use this one. And I'm just going to import that into the project. Let's come up on my other screen so you can't see it, but there it is. So I'm going to import that in. Okay, so that's now imported into the project. The next thing that we're going to do is we are going to create a new folder, and we'll call that scripts. And then in this folder we're going to create another one, and we're going to call this model. Okay, now in here we're going to create a new script, and we'll call this weather response. Let's call it weather response. I'm going to double click that, and I'm going to open it in Visual Studio. Okay, and we've got an empty class there. Now, what this model is basically just going to be our response from Open Weather Maps. Okay, so as such, we don't need to inherit from mono behavior anymore. Okay, and we also do not need these two methods here anymore. Okay, because this is just a model class. What we do need to do is we need to go back to Open Weather Maps. We need to copy the response here. Okay. And then we need to go to our JSON to C# and click on generate. Okay, now as we saw earlier on, this now creates our classes, and you'll see that there we have the overall root object here at this level, and it creates a class called weather. Oh, actually, sorry, it creates a class called coords, and that's there, and weather, and so on. So it's got the whole object there. So if we copy that, I'm just going to do that, and I'm not going to do it again. Now, if we delete that all there and then paste, and that's not right. Hang on. Let me do this manually. Right, copy that, get rid of that, paste that. Okay, there's all our classes. Okay, now the one thing that I want to do is I want to change root object to be weather response, because I don't like root object. Okay, there we go. So now in our Unity project we have our weather response. Now it's time for us to get into our user interface. As I said at the beginning, this is going to be terrible, but you know, how many apps do you see with a terrible UI? Well, possibly quite a few of you have seen some of mine. Anyway, so we're going to go to create game object and text. Okay, we'll create a bit of a text. We're not going to bother about layout too much. I'm just going to make this bigger, maybe bigger than that. Let's see, that big. Might have to stretch this out. There we go. Okay, and let's also add a button. there's our button. Right. The next thing we're going to do is we're going to add a new empty game object here, and we'll call this weather. Didn't need to be capitals. Weather. Okay, and next we will add a new script to this called weather request. That's already filled in. Cool. There we go. Let's create that. Okay. That created it in the root. What's going on? There we go. Okay, we're just going to move that to our scripts folder. Keep everything nice and neat. Let's open that in Visual Studio. Okay. Now, this script is going to be responsible for making our actual weather request and displaying the temperature in our text field. Okay, so the first thing we're going to do is we are going to get rid of these again because we don't need them. Let's get rid of that comment there too. Right, we need a variable to handle to contain the URL to our weather request. Okay, so we're going to make this private because we don't need to. It doesn't need to be seen anywhere else. It's a string, and we might as well just call it URL. Okay. Then we are going to paste in our the URL to the OpenWeatherMap call, which also contains your app ID. The next thing we're going to do is we are going to create a variable that will reference the text field that we put down, which is of type text, and we'll just call that temperature. There we go. And that's okay. Okay, right. So we need to put we need to add a reference to the Unity Engine UI library, which is why that text there is underlined. So if I just add that there like that, see, it resolves the name, and we can carry on. Now, as you should know, Unity works on the basis of frame rates, so everything it does is dependent on the speed of your computer and how many frame rates in terms of animation and everything. But if you make a request to a network resource, you cannot guarantee that you're going to get a response in one single frame. You know, the network can run slow, there may not even be a network connection. So what we're going to use is a special function called a coroutine, which is sort of a Unity's implementation of an iterator pattern. Okay, so the way that we do that is we are going to create a method with a return type of our enumerator, and we'll call that make weather request. I don't know why I put a space there, or equal signs. Okay, and in this method we are going to handle our actual communication with the web, and we're going to do that using a Unity web request. Okay, now it's going to underline that again because it's going to expect me to bring in another package, which is using Unity networking. So we'll bring that in, and we'll call that request equals Unity web request, and the type of request we're going to do is a GET request. there are lots of different, well, not lots, but there's a few different types of requests we can do depending on the type of operation, whether we want to get information or send information, etc., etc. In our case, we want to get, so we're going to use a get, and the get request requires a uniform resource locator, which is our URL there. So that's that. Okay. Now, for the enumerator pattern to work, we then have to do something. We have to yield return request dot send web request. Okay. Now, what we need to do next is to check whether there was an error there. So if we do if request dot is network error, or request dot is HTTP HTTP error. Okay. If it's either of those, we just want to write that out to the debug console at the moment. If it was an actual, hang on a minute. If it was an actual production app, you might want to do something a bit more sophisticated, but it's good enough for now. Okay. Else, this is not the best coding style, by the way, but it's just good enough for this. Okay. If there's no error, what we want to do is we want to get the result and turn it into our weather model. So we want to take that JSON that we saw and we want to map that to the weather model that we created, and we use NewtonSoft JSON.net to do that. So we'll create a variable for our weather, and then what we're going to do is we're going to use something called JSON convert, and we're going to deserialize the object. I'm going to need to import this in a sec. See, using NewtonSoft JSON there. Okay. If we don't import it in, then it doesn't give me IntelliSense and automatically fill things, and then I have to remember stuff, which is never a good idea. So we're going to deserialize the object. Now you see here in the list we've got two. We've got deserialize object, and that takes a string value, or we've got deserialize object with these brackets. We're going to use the one with the brackets because this means this is called generics. Okay, what it means is that we're going to tell it the type of object that we're expecting to get back. Okay, and the type of object that we're expecting to get back is a weather response, which is our model. I'm not going to go into generics too much at the moment. We'll save that for a later day, but it's very cool, and it basically means that it can handle just about any object. That's a really bad explanation, actually. Just leave it for now. But if you imagine if we didn't have generics, we might have to write a class that would just deserialize a weather response, and then we might have to write another one that just deserialized a recipe or something like that. It would be terrible to do that. Generics takes care of this for us. Okay, so we're going to pass in our request, okay, and the download handler and the text, which is the text, which is the actual response that we're interested in. Okay. Now at this point, what I'm going to do is I'm just going to do this. Actually, I'm just going to say var t equals weather. Okay, and the next thing I'm going to do is I'm going to go over the side here, and I'm going to click, and I'm going to put what's known as a breakpoint here. Okay. Now, we're going to go back into Unity. Okay, we're going to go to our button, and we've got this on-click thing here. Okay, we're going to add something in there, and we're going to drag our weather object to it there. Oh, sorry, hang on a minute, I've forgotten to do something. Let's go back to our script. We need some way of actually calling this, so I'm going to create another method, and I'm just going to call this public void. Void means that it doesn't return anything, and we'll just call this get weather, like that. And in this, what we're going to do is we're going to start our coroutine. Start coroutine. Make weather request, like that. Okay, let's save that, and let's go back here, and hopefully this is all synced up. So we've got our weather object, which contains the script that we've just been working on. So we'll select the function here from weather request, and there should be in here get weather. There it is. Okay, now hopefully I've done everything right. What we're going to do is we'll click play here, and we've got no errors, which is good. Okay, now we're going to go back to Visual Studio, and we are going to, on the debug, we're going to do attach to Unity, and click on that. Right, and we're going to make sure that we've got locals still up. Alright, let's go back into Unity, and we're going to click on that. Right, okay, so I don't know whether you can see that, but we've got an error, and the error says input string is not a valid integer. Can you guess what that means? If you can't, let me remind you. If we go back to our weather response model, if you remember, I said about lat and long. Now, in this, it said it was an int, but you know, I know latitudes and longitudes, and usually they've got a decimal point after them. Okay, so what we need to do is we need to change this from an int to a double. There we go. Let's save that, and let's go back here. Now we're going to play this again. No errors, which is good, always good. And then attach on Unity is there. Let's click play again. Okay, locals is available. Click on this, and this time we get no errors. And what's happened is Visual Studio has now stopped at this point here where we put the breakpoint, which is perfect because that's exactly what I wanted, because I want to show you these are all of the variables that we have in scope on this execution, and you'll see weather here, which relates to our weather here, and if we expand this, you'll see all of the information, which is really cool. So our JSON convert deserialise has done its job, and it's turned all of that data into the model class, which is perfect. Okay, so I just wanted to show you that because it's quite important. So if we stop that and then stop this, what we'll do is we'll finish the implementation. So let's get rid of that. We don't need that. That's just for testing. Now, we created a variable for our text object. Okay, so we need to get that now. The way that we do that is you go temperature. Okay, and we want game object. Okay, and find temp. Oh god, punctuation issues. Oh dear god. Temp. Okay, and get component is of type text. You can see those angle brackets again. Again, this is a generic function. Okay, and then temperature. And we'll set the text. That's the text property of the temperature object, and we're going to set that to weather.main. Okay, why am I saying main? Well, if you remember from here, main contains temperature. Okay, main dot temp. Now temperature is a double. You recall, well, don't recall, it is double there, so we're going to need to cast that to a string, and we do that by using the toString, well, with a dot there, toString method. Okay, so there is one other thing that I've just forgotten. Okay, is that our text needs to be called temp, otherwise we won't know what it is when we're getting it here. Okay, now let's make sure that's saved. The way that you can tell whether things are saved or not is that if it wasn't saved, this little X would be an open circle, and I can show you that. See, just made a change and now it's become an open circle. So save again, and there you go, cross. So if we run this now, when I click on this, it sets the temperature there, and now we have our weather app. It's cool, isn't it?